Hello, physics students from WCA. This is Miss Peachy, your physics teacher. And today I'm going to be showing you what you need to do for your Lesson 5 lab. I think this is Unit 2. Yeah, Unit 2, Lesson 5, your lab on projectile motion. So instead of giving you two different choices for this lab, I'm just going to have you do my alternative lab. I'm not too thrilled with the labs they have in the lessons. A lot of the materials are difficult to come by and they're kind of hard to carry out and to do so well at home. So we're going to be using a sim for this lab instead. So right away when you get to this lab, I want you to go to my website so you can kind of see what you need to do. So I'm going to go ahead and open that up. And just remember that if you don't know how to get to my website, you are going to go to that push pin icon at the top of your screen to your section message boards. Find your physics section message board and then follow the links to my website. I'm just going to scooch my picture over a little bit here because you're going to click on physics. And then when you scroll down, you'll see you had the first lab here. Sometimes my website's going to load a bit slow. I apologize for that. A lot of people using some the internet here at my house. So we have lab 2. This is the worksheet, and this is the video directions that I'm making right now, so that's not posted yet, right? So you're going to click this and open it up. And then this is going to open up in your Google Docs for you, okay? So when you open this up in Google Docs, you cannot edit this at this time. You can either make a copy of it, so you go to File and make a copy. If you're used to using Google Docs, you'd know about that. Otherwise, you can download it as a Microsoft Word document to your computer to then edit and that kind of stuff. These are just the directions, however. You are writing up a lab report for this portfolio. In fact, going forward, I expect that we'll be doing lab reports for all the portfolios. That's what I've always done in the past. This is a fairly new physics curriculum at this time, so kind of modifying it to kind of follow the same thing we've done in years past. Simply because I feel like it's a really good experience to be able to write these lab reports and very good preparation for how you're going to have to do that in college when you get to your college courses, and physics is a college prep class, so it's a good experience to have. So what you're going to do is you're going to be using a website called PHET, P-H-E-T. Okay, so PHET has a lot of really cool sims in it. You did use it if you did my online alternative for the first portfolio. You were using PHET as well. So let me just kind of bring that up here. When you open PHET, it will look like this. Okay, and you're going to go to the lab, which is the last thing on here. Click on that and open it up. Now, according to the directions here, you're going to be testing two different variables. So we're going to do all of our projectiles launched from horizontal. We are not having an initial angle here. It makes the math a little bit more difficult. So we're just going to, at this point, do just projectiles launched from horizontal. So when you see your cannon, it's not horizontal to start with. You need to move it so that the angle is horizontal. That means you actually have to raise the cannon up to do that. Just click and drag so that the angle is at 0, okay? That's your first thing you want to do. And then the two variables you are going to be testing, you are going to see how initial delta y affects both the delta x and the time to hit the ground. So your first variable is going to check kind of the relationship between how high that cannon is, or the height the cannonball is launched, and how far it goes and how long it takes to get there. So that's what you're going to do first, is you're going to have 5 different trials where the delta y is at 5 different numbers. So you'll make a data table with 5 trials, and you'll pick 5 different delta y's. So here it's at 2 meters. You know, maybe I can raise it up to 3 meters and then 4 meters and so on. So, but that's the thing you're changing. So this is your independent variable for this trial, is going to be your delta y. When you launch the cannon, then you just push this little fire button. At this point, we don't need to worry about this target, ladies and gentlemen, because we're not really using this, so I can just get it out of the way. You can, use this portfolio or use this this tool here to try to predict the delta X and then try to hit the target, but that's not what we're using it for. We're going to launch the cannon, and it's going to hit the ground. And then what you need to record in your data table is how far it went and the time it took to get there. So I'm going to take this little tool here, up here, and I'll take it down, and I'm going to put it right on the cannonball right there. And it's going to tell me that it went 16.25 meters and it took 0.9 seconds. So those are the two pieces of data from that trial that you're going to record in your data table. Okay, so for the first data table, you're going to create a table with 5 trials, a column for initial speed. You're going to keep the initial speed at 18 meters per second. That's the default speed here. Okay, and then you'll have a column for delta Y. That's the ones you choose, the 5 different heights. A column for delta X, which you'll measure using that range finder, and a column for time, which you're also going to measure using that range finder. Then the second thing we're going to test is we're going to see how the initial speed affects delta X and time. So in this case, I'm going to reset everything. You can kind of use this tool over here to reset it all. Come back again. Remember, this has got to be horizontal. So we're going to raise this platform up to 5 meters for every single trial this time. So the delta Y stays the same. Make sure that's at 0. And what you're going to be changing is the initial speed. So you're going to pick 5 different initial speeds. And again, for each one, launch the cannon and see how far it went and how long it took to get there. So delta X and the speed. So that's your second data table. 5 different trials, a column for initial speed. That'll be different for each trial. A column for delta Y, which will be 5 meters for each trial. A column for delta X, which you are measuring using the rangefinder, and a column for time, which you are measuring using the rangefinder. So those are the 2 data tables that you're going to have. Then you are going to write up a lab report. And in that lab report, you need to include the following sections. So you'll have an introduction and hypothesis section. So in this section, you're going to talk a little bit about projectile motion. What is projectile motion? How is it measured? How is it calculated? Give some background information, just like we don't know anything about projectile motion at all. To get full points in this section, you will need to cite something from your lessons, like an in-text citation. Okay, so you're also going to have a hypothesis regarding our 2 different variables being tested. You can combine them to make a single hypothesis, or you can do 2 separate hypotheses. But remember, we're looking to see how initial speed is affecting both the distance and time, and how the height that the projectile is launched is affecting both position and time, delta X and time. So you probably want to have 2 different hypotheses. Again, if you can give me an in-text citation, so something from your lessons that supports why you think what you do, that's going to be what you need to have full points for this section. It's very important to be able to use those in-text citations. Then you'll have a data and graph section. You will include the data tables I described before, and you will also have 4 graphs for this section. The first graph should be vertical displacement, so delta Y versus delta X of data table 1. The second one is vertical displacement versus time. The third one is initial speed versus time. And the fourth one is initial speed versus horizontal displacement. Now, remember when you're doing your graphs that the dependent variable always goes on the y-axis and the independent variable always goes on the x-axis. That's very important. Dependent on the y, independent on the x. Labels on both the axes, both the units and the labels on the axes, and also a title for the graph, okay? Your third section is your analysis. In this section, you're going to do 2 things. You're going to give a written description of the trends or relationships you see in the graphs. Okay, so as one variable increases, the other one increases. Is there, a linear relationship here? Is it direct or indirect? Those types of of things. You don't have to have the math vocab in there if you don't say inverse or directly proportional or things like that, but you should be able to tell me if they're related to each other. Is there a relationship or is there no relationship? And explain. And then also any and all calculations. Now, I don't think you have calculations for this particular portfolio, but going forward, you probably will. So if you have another portfolio where you have to do math calculations, you actually have to write all the calculations out. It's really important because if you screw up and come up with the wrong conclusion, usually I can see why in those math calculations. So it's very important to make sure you have those. And then finally, the conclusion section, you'll answer these questions that are written here. Basically, you're concluding about your relationships that you've been looking at, and you're also going to compare it back to your hypothesis. Now, this is a little bit more work than we expected from you in the first portfolio, so it's worth double the points. In the gradebook, it says 10 points, and I left that in there. And then I added a custom assessment for an additional 10 points. So you'll have a total of 20 points for this, okay? So you're going to see it divided into two separate categories. One is just the lab grade that's already in your gradebook, and the other one will be a custom assessment. So you'll have to add those two together to get your total points for the portfolio. All right, so hopefully that all makes sense to you. It's not super difficult, but I do want you guys to get used to the format of writing up those lab reports because, as I said, that's something that you'll be doing in all science classes kind of going forward, and actually what scientists do. So it's important too because it's part of the process of science. If you have any questions, feel free to send me a webmail message, and then we can maybe get together and meet in my live lesson room so that I can help you out. Have a great day, everyone.